Okay, so 24 part 1 asks us to sketch these two graphs, and in particular we have to state the equations of any asymptotes and the exact coordinates of any intersections with the axes. So mine will be a little messy, I'm afraid, because I'm drawing on a computer, but I'll do my best. You just may hear me go quiet for a bit as I'm displaying extreme feats of concentration. So what have we got? Well, let's take a look at this graph first. Y equals to 1 minus 2x over x minus 3. The first thing that should strike you is that the bottom line, x minus 3 on the bottom line, that means that at x equals to 3, there has to be a vertical asymptote. So this is x equals to 3. The other thing that you should recognize is that this is a rectangular hyperbola, so there should be a horizontal asymptote as well. For the horizontal asymptote, we consider what happens as x becomes very, very large. Well, as x becomes very, very large, this thing approaches negative 2x over x, because when x is huge, this 1 doesn't matter and this minus 3 doesn't matter, right? But of course, when this happens, the x's just cancel, and so that this is about minus 2. So we actually get a horizontal asymptote at y equals to negative 2. What about our coordinates of intersection? Well, when x equals to 0, y is equal to 1 over minus 3, so that's negative a third. So that's going to be about here. And so this is negative 0, negative 1 over 3. And when y equals to 0, that means that this top line must be equal to 0. So 1 minus 2x equals to 0. That means that x has to be a half. So about here. 1/2, 0. And so this is enough for us to get a decent sense of what the first graph should look like. As always, you start close to the asymptotes and you tend towards the asymptotes. So always getting closer, and see that like little flick at the end there? That's bad. You shouldn't have that flick, so try not to do that, okay? And of course it's a rectangular hyperbola, so it should look the same in the other quadrant that it should be in as well. So you get something that looks like that. This is the first graph. What about the second graph? So I'll use a different color for this. Let's look at y equals to ln 9 minus 2x. Well, we know that this one is undefined if I get ln of 0. So this one is undefined if I make the bottom line equal to 0. For a ln, for a logarithmic graph, it's undefined if this bit on the inside equals to 0. So to find my horizontal asymptote, I just solve 9 minus 2x equals to 0, and I find that x is equal to 4.5, or 9 over 2. So I know at 9 over 2 there is a vertical asymptote, sorry. So this is x equals to 9 upon 2. I know that there is no vertical asymptote, so this is very important. No horizontal asymptote. So this is very important for a ln graph, although it looks like it's, you know, the general shape of a ln graph is something like that, and although it looks like it's flattening out, it never fully flattens out. So there's never a horizontal asymptote, right? It grows really, really slowly, but it's always growing. So, what does that mean? That means I don't need to worry about horizontal asymptote. What about the x and y intercepts? So we set, let's just erase this down here. When x equals to 0, what do I get? I get y is equal to ln 9. So ln 9 is a positive number. In fact, I think it's about 3. So I'll just mark that out here. This is 0 ln 9. And when y equals to 0, I get ln 9 minus 2x equals to 0. So that means that 9 minus 2x equals to 1. That means that x equals to negative 4. No, not negative 4. X equals to 4. Good. So I get a point here. This is 4.5, so 4 should be somewhere around here. I get the point 4, 0. So this gives me enough information to draw this curve. It starts as usual close to the asymptote and very, very close, very, very steep for this part. Hits there, comes across, comes across, passes through there, and grows in this direction. And you'll notice that this time it's going from right to left as opposed to our usual ln curve. So usually we think of the ln curve as going like that, but this is when ln x is positive. So if I wanted to look at ln minus x, that would of course have to go into the negative direction. So that's what's happening here. This is ln minus x, and so I've got a negative sign in front of my x here. That's why I'm going from right to left. So my graph should look something like this. So there was a little something I did forget. I should always label my curves. So this is ln 9 minus 2x, and this one here is y equals to 1 minus 2x over x minus 3.